to do that.
You probably can block on.
I'm only one person.
Okay, here we go. We're on 7.6. We're still doing our card problems. Now we're ready for problem E. I want the probability of getting all queens. Now, we've talked about the fact that our denominator isn't going to change. Solomon, I need your 100% attention, buddy. The denominator isn't going to change until I start picking a different number of cards. But as long as I'm picking 3 cards, it's 52C3. Now, I want all queens. All right? So how many queens are there total? 4. And I have to pick 3 of them? This is going to be a really small number. Because you can imagine that now, this on my calculator, I'm glad this happened, because on my calculator, what are you doing back there, Brandon? Okay, are you paying attention? Are you typing with us? I need you to type with us, okay? And if you don't have a calculator, then you need to scooch over and make sure you're practicing with somebody else's. Okay, so I got my number came up in scientific notation. So that's fine, but you need to translate it then into a decimal. So when it says 1.80995 4751 times 10 to the -4th, that means 1, 2, 3, 4. So then I fill all the shells with eggs, and it's 0.0001, and then all that. Now on the test, I'm having you round to the 10,000. So this would actually be an 8 after this. So I'm going to round that off to 0.0002. But I'm kind of uncomfortable with that number, so I might math fract it.
That's what I got.
Oh, shoot.
Oh.
What happened when you math fract it?
Error, brother.
I didn't get it. 1 over 5,000.
You got a fraction? Oh, good. What is it?
1 over 5,525.
5525? Why didn't you do that? I wonder why.
I got 1 over 5,000.
I don't know what y'all doing wrong, but
I got what Sean got.
yeah.
My calculator fucked up. Can I go to the restroom?
Math is an emergency, sure. Thank you, because
Why you still always
you don't
lying?
need to be in class. Okay, so this was 3 queens. We got this big ugly decimal. We rounded it off in decimal form. Or some of your calculators, when you math fracted, you got a fraction. Yeah, that's right. I don't know why mine didn't do it. Okay. Next, what was that? EF. I want 2 queens and 2 kings. What? About what?
So when you're at 1 point whatever and then E, how do you get it to 0.002?
It's scientific notation. You're just moving the decimal point to change it back into decimal form.
And then you just round it.
Well, I did because the test says 10,000, so I rounded it off to the 10,000th
Sorry, I
place.
didn't mean to switch up.
Well, you've done scientific notation for a long, long time, and this is no different. This is regular scientific notation. We're just converting it into a decimal. All right, 2 queens and 2 kings. All right, so got my denominator because that hasn't changed.
52.
Yep. What about 2 queens? 2 queens. What does that look like? How many queens are there?
4.
How many are we choosing?
2.
So 4C2. How about 2 kings? How many kings are there?
4.
4. How many are we choosing?
2.
2. So we are picking 2 queens and 2 kings. So those 2 are going to be multiplied. Oh shoot, I got another scientific notation. I got this one, I rounded it off.
0.02714.
Oh,
What is that? I got .0016. Yeah, I got .006. I got .0016.
let's have a mistake. Let me try again.
Fractionally should be 9 over 1.527.
I got 0.0.
Oh, I know what happened.
What happened?
It's
I see what I did
0.0016.
wrong. Yep. Well, I don't know what it is, but it's not what I have up there. I know that. I found my mistake. Yep. So it is .0016 if I round it off. And then 9 over 5525.
Yes.
Boys. E period got new seating arrangements because they couldn't keep their mouths shut. Okay, so this was 2 queens and 2 kings, and so that's the right answer. Okay, John? Can't hear you, what?
If it's 2 queens and 2 kings, why would the denominator stay the same?
I'm only picking 3 cards, yeah. That's, I don't know, that just flew right over my head.
I was thinking that too.
Yeah, well, I'm glad you were thinking, because I wasn't. I don't know why, it would be impossible. So if we literally meant the problem to be 2 kings and 2 queens, that would be impossible if I were only picking 3 cards. But let's go ahead and do it.
For 4.
Yeah, and change our denominator so that it becomes a possible problem. I didn't even catch
I
that.
did it.
John, thank you. If anybody else noticed that, I didn't even catch it.
Yeah. It's because all this talking.
Now, I got another scientific notation thing. So .0001329. So I have to round that off to .0001. And mine won't math frac, which somebody's might.
I'll go first. I didn't either this time.
Like, how many decimal places you have?
4. Well, yes, you gotta move it 4 places. It didn't either? Okay. So that's just it. Sometimes when those decimals get too long, there is a fraction that represents that decimal, because if we were doing these problems by hand, you can actually do these calculations by hand. It would come out to be a fraction. So I know this converts to a fraction, I just don't know. It must be too far out for the calculator to get it. That was a very good catch. Those of you that noticed that, awesome. 2 kings and 2 queens, I would have to be picking 4 cards to make that happen. All right, let's go back to G. And let's go back to 3 cards. So we're picking 3 cards. So our denominator is going to be 52C3.
Yes.
Now we want exactly 2 queens. Okay, now stop and think about it. We want 3 cards, right? And we want exactly 2 of them to be queens. So what is that numerator going to look like? 4C2 takes care of the queens. So there are the queens. There's 4 queens in the deck, and we're picking 2 of them. 48C1. Because the other cards have to be not queens. And so if there are 4 queens in the deck, there are 48 cards that aren't queens, and I want 1 of those. Don't care which one, but I need 1 of those. So this is, there's 4 queens and 48 not queens. I want 2 from the queen pile and 1 from the other pile, the not queen pile. So what did you get?
0.0130.
And what was it fractionally? 5,525. Okay, let's see if we get a confirmation on that from someone.
I got that.
You got that, Ramona? Okay.
That was so funny. Oh my gosh.
H says no more than 2 queens. What in the world does that mean? No more than 2 queens.
You want 2 queens, exactly. Or 1 or 2.
I could get no queens, right? I could get 1 queen, or I could get 2 queens. Would everybody agree? Now, did you hear the word as we were going through that? We said we could get this, or this, or this.
Yes, we're adding.
So we're adding. So we're going to find these 3 separate problems and add them up. Now, this one we already did. This was exactly 2 queens, and didn't we just do that one? So that one came out to be 72 over 5525. Why am I using the fraction form?
More accurate.
Yeah, it's accurate. There's no round off in that, right? So if you want to use the decimal forms, that's fine, but don't round them off every step you go, okay? So let's do no queens. What is that going to look like? 52C5, 52C3, what is that going to look like? No queens.
4C0.
Okay, I can say 4C0, there is never a need to put that in, but if that helps you understand, that's okay. That means there are 4 queens and we're taking none of them. But what are we taking? We're taking 3 of the other 48, aren't we? Kids, it's a 3-card hand. I gotta have 3 cards. Where are they coming from? The non-queen stack. This will never, this is 1. The value of this is 1. So it's never gonna make a difference in your problem. So you do not need to include it. But if you want to, you may. This says no queens and 3 other cards. Okay?
It was 0C4.
Then work. How can you have 0 and choose 4?
No, I was gonna say.
Yeah. The first number tells me how many I have to pick from, and the second number tells me how many I picked. Okay. Now, what does 1 queen look like? I'll take that in a minute, but what does 1 queen look like? 4C1 times 48C2. And then I'm going to go ahead and erase this and remind you what that was. That was 4C2 times 48C1 over 52C3. So do you kind of see what's going on here? There's kind of a pattern. We're picking no queens out of 4, 1 queen out of 4, and 2 queens out of 4. And then the other cards in my hand are anything else. So here I needed 3 of them, here I needed 2 of them, and here I needed 1 of them. if I am doing this problem on my own, I notice that all the denominators are the same, right? So I'm not gonna type this in individually. I'm going to type in on my calculator this. Well, I'm not even gonna type that. I'm gonna type 48C3 plus 4C1 times 48C2 plus 4C2 times 48C1. I'm gonna type all that in. I'm not gonna write it down. I'm just gonna type it all in. I'm gonna hit equals, and then I'm gonna divide it by this.
You don't get the first one, 4C0.
You can type it in if you want, but it's 1. 4C0 is 1. If you're picking 0, then you have to
Yeah.
write it down. But if you do, it's okay. If you type it in 4C0, it'll just come out 1, but that's fine. So on these multi-piece problems, I like to do all the numerators and then hit equals and then divided by your denominator. That way you don't have to type in the denominator 3 times. You're only typing it in once. All right, now I'll go ahead and type that in 2 and see if we match. 48 C3 plus, yeah, they take a while to type in. There's 3 of them on your test.
Like I said,
That's a good one. 3 of the multi ones or just 3 do?
4 problems
I
like
got
this.
21, 8, 20.
Now I'm losing track.
I didn't get a fraction.
Does it look like a 20?
She gave me money. Is that what you got?
Why didn't you check
I didn't get 21.
I didn't get it either. I got 0.9 something.
21, 8. That's right. I get 0.99. I got the same.
Oh wait, have you divided by the denominator yet? Okay, all right, so let's talk about this. Somebody up here is getting an answer of something like this. Okay,
Yeah, that's not what I was gonna get.
now, kids, what are we finding? The probability? Can the probability be 21,000? The probability needs to be a something less than 1, right? 1 or less. So I actually got 0.9998 as mine. Did anybody match that?
Yeah. No, I didn't. I'm gonna do it again.
I typed in exactly what's written down. When you get to the end of the top, make sure you hit equals and then divide by the bottom. Okay? Now, it's real easy to get distracted, especially if your neighbor's talking, messing with you, and lose a number in here or type a wrong number, so you have to be careful. But type in the whole numerator. Excuse me.
Bless you.
Thank you. Hit equals and then divide by the denominator.
Okay, well, I would have had it right if I didn't have to do
Okay. We're almost done with the card problems, and then we'll do it differently. What's the probability of at least 2 queens? So I'm still picking 3 cards, but I want the probability of at least 2 queens. Okay? Solomon? You're never coming back very flex if you don't pay attention in class. Okay? It starts right now, this minute. Turn around, whether you like it or not, look at me. Okay? Here we go. At least 2 queens. How does that happen? At least 2 queens. What does that mean?
2 or more.
I could get 2 queens, or I could get 3 queens, right? Now I can't get any more than that because I'm only picking 3 cards. But I could get 2, or I could get 3. Now, the denominator of the whole shebang is 52C3, so I'm not going to write a bunch of individual fractions. The numerator is 2 queens tell me what does two queens look like? We've already done it. Two queens looks like 4C2, those are my queens, times 48C1. That's my extra card. A lot of times kids forget about that extra card because it says two queens. But you gotta remember it's a 3-card hand. So if there's only two queens, the other card has to be something else, right? Or, so plus, what does all 3 queens look like? 4C3, there are 4 queens, I'm picking 3. And then if you want to say 48C0, you can, but remember, if you're picking none, then there is no reason to write that down. But if the pattern makes more sense to you that way, that's fine. So now, we're going to type in the numerator, and we're going to hit equals, and then we're going to divide it by 52C3. And our answer is decimally, I got 0.0132, and then fractionally, I got this.
Why is my calculator not?
Well, I might have made a mistake. I've made a couple here today, so let's.
I got that too.
I got
Oh,
that
every
too.
time.
I'm good?
Yeah.
If what you got, I'm good. Is that what you're saying, Anthony?
No, it's like every time I do the fraction part, like I get the decimal right, then I do the fraction part, and it does not come out. Every time. You get this right. You do not get that decimal. Oh, and they get your sandwich.
Okay, one more card problem, and then we're moving on to something different. We want to get 2 diamonds and 1 heart. 2 diamonds and 1 heart. So, what does 2 diamonds look like?
How many cards are we pulling?
13C2.
I don't know how this happened.
I don't know either. Turn it off.
Cake numbers?
What? Oh, time.
Times, because we are getting 2 diamonds and 1 heart. How do I get a heart?
13C1.
13C1. So there are 13 diamonds, and I'm picking 2. And there are 13 hearts, and I am picking 1. So this is just a straight, no adds, no ors or anything going on here, just. .0459 or 39 over 850. Anybody match that, Anthony?
That's correct.
Okay. Q says it's right.
That is correct.
That's correct.
All right, so we've practiced a lot with card problems, but these do not have to be, I mean, you can do the same thing with lots of situations. So let's look at number 2, problem number 2 on page 17. We have 10 juniors and 16 seniors. And we're going to choose a committee of 5. Okay, so this is exactly like the card problem, only we're picking 5. And instead of having diamonds, hearts, clubs, and spades, now we only have juniors and seniors. Okay? So it says, I want to get 2 juniors and 3 seniors. So it's a probability question. What will my denominator be?
26C5.
Perfect. 26C5. Why is it 26C5? Because there's 26 people to pick from, like cards in the deck. There's 26 of them, and I am going to choose 5. Now my numerator says I want 2 of them to be juniors.
Multiplying or adding?
So 2 of them to be juniors would be what? 10C2. Someone said it. 10C2. And 3 seniors. 16C3. Now, since I'm picking 2 and 3, what will I do with these 2 numbers? Multiply them. Okay, I'm going to multiply them. Because why? Every time it's an and, we multiply. I know, I don't know how to make people remember it. Every time it's an and, we multiply. All right, tell me what you got. Type it in, tell me what you get.
0.3830.
0.3.
830. 1,260 over 3,260.
All right, so do we have confirmation? Decimally and fractionally? Liam, are you typing this in on your calculator? No. All right, try B and C on your own. Check your answers with your partner. So B is no senior, or wait, B is all seniors. And then D is no seniors. Pay attention. You're finding a probability now.
How come I get the same decimal, but when I do the fraction, it doesn't come out to the fraction? Sometimes it does, sometimes it doesn't.
Well, you have to leave the unrounded decimal in the calculator. So whatever that decimal came out to be, you do the unrounded decimal. When we get around to the test next week, your setup is worth half credit and the right answer is worth the other half.
Okay, because I thought since they're all
I'm not the front kid.
no, it's just 65.
That's how you get the front kid. I'm at the front
Did you
kid.
choose 5?
That's what I did.
Sorry. Have you watched me? You don't
I guess.
Like, the nanny and
Jessie would probably.
Yeah,
She'd be like, oh, she was doing that the other day. I don't know why she did it. She was just.
Maybe 26 is
That's
cool.
kind of like authentic laughter.
It's like that video where it's like just.
I don't know what's
My first one turned into a fraction, but my second one didn't. I don't know. Too many places to round out because they are all fractions. Okay. Who will share your setup for the all senior problem? Mike, is your hand up back there? Okay, you want to tell me how you set up all seniors?
Yeah. So the top is 16C5, and the bottom is 26C5.
Perfect. And what answer did you get, Mikey?
066.
That's unacceptable.
I got 0.0664 or 84 over 1265. Okay, Mikey, make sure you know how to type all this in.
I'll do the second one, but I don't know if I can.
Okay, so what was your setting?
I did 16. And I multiplied it by 10C5. And I got
Okay.
point.
Now, the Muna set up the no senior problem like this. This is how she set the problem up. Did everybody set it up this way?
No.
Did some of you leave this part off? Because anytime we're picking zero, it isn't wrong. What she's telling us is I got 2 groups of people and I'm taking nobody from that group and 5 from this group. And it is perfectly okay to do that. It's extra stuff to type in though. If you are picking 0, it will never impact your answer. So feel free to just not type it in. Even if you write it down, you don't have to type it in, okay? Because anytime you pick 0, it's 1. Child?
So, I'm confused, like, so all seniors would put 60, I got that part, but why would just no seniors? Like, even though you raise them, like, you don't have to fill it.
You don't have to. You can. So up here, if you wanted to put 10C0, no juniors, you could. Okay, but now listen to me, Charlotte, because I said this 5 times. Whenever you pick 0, it will never impact your answer. So write it down, don't write it down, who cares? It isn't gonna make a difference. And it takes extra time to type it in. All right, here we go, one more. At least 4 juniors. At least 4 juniors. Now stop. You're picking 5 people. If we say at least 4 juniors, what does that mean? Izzy?
You could have 4 juniors, or you could have 5 juniors.
Exactly. Now, nobody ever misses this part because everybody will say, oh, 5 juniors, that's 10C5. Period. Everybody gets that part. What happens is on this one, people will say, how many seniors are there? 16C4. That's not enough. That's right so far, but how many people are you picking? 5. So if you are picking 4 seniors, you must also pick a junior, right?
You got it wrong. Flip-flop.
Oh, did I? Oh, I did see, I need junior, so yeah, thank you. So 10, 4, and 16, 1. Yep. And then that's right. So 4 juniors would be 4 out of the 10. But since you're picking 5 people, you also have to have a senior in there. That gives you your 5. Or you could have all 5 juniors. So this one is a multiply because it's 4 juniors and 1 senior. This one's an add because it's 4 juniors or 5 juniors, right? So then we'll type it in. I don't know if I can trust you guys or not to give me the right answer. Did you get 0.0549?
Yeah.
Now that one didn't change either. One last comment. If you really, really need a fraction and you can't get it from the calculator, remember, when you type this in right here, you hit equals, right? And when you hit equals, it was 3612. my denominator.
Mrs. Ford, do you want me to turn this off?